also. I need some responses from you. Okay.
ओके। ये भी ज्वाइन करके किधर चले गए?
कौन?
यही जो ज्वाइन किए नए मेंबर्स वो किधर है? वो भी कुछ रिस्पॉन्स नहीं कर रहे।
Mm-hmm. Arif is not responding.
Yes,
Arif,
I'm here only.
हाँ।
Safa, Safa.
Yes, ma'am.
Uh, Hello, Safa. I'm your new faculty. My name is Suhasini.
अरे वो निकाल में मैम
See,
देखो
12 to 1, everybody need to take out your time and you have to focus on the syllabus. Okay. If you have other responsibilities also, keep it aside. Okay.
ओके मैम।
हाँ। और पूनम, और कोई ज्वाइन हो रहे? कोई इंटीमेट करे? नहीं तो हम शुरू कर लेंगे।
एक मिनट। हाँ, इस रिस्पॉन्स तो कर रहे हैं कि हाँ ओके, बट ज्वाइन अभी करेंगे नहीं
ज्वाइन
करेंगे।
हो जाओ बोल के बोलो ना। नया मैडम आया है, मैडम को तो बहुत इंटरेस्ट है सिखाने के लिए, बोल के बोलो ऐसा।
हाँ।
एक बार क्लास सुने तो पता चलेगा ना, क्लास इंटरेस्ट
यस।
है कि नहीं है। पहले
यस
सुनना
मैम, यस मैम।
इम्पोर्टेंट है ना, वो फर्ज तो निभाना।
हाँ हाँ। मैम ग्रुप में लिंक शेयर कर दीजिए, लिंक पूछ रहे हैं लोग मेरे से।
कौन से ग्रुप में?
एक मिनट। लिंक पूछ रहे हैं।
हम्म। तो
गो
शेयर कर दो।
गो टू ग्रुप बस।
पूरा मेरे स्टूडेंट्स जो भी है, आई नीड ए ग्रुप ऑल्सो,
हाँ।
सो आई कैन
ओके।
शेयर यू द मटेरियल। जो भी इंपॉर्टेंट क्वेश्चन है वो सब मैं शेयर कर सकती हूँ। पूनम, विल यू टेक दैट रिस्पॉन्सिबिलिटी?
ओके मैम।
ओके। So, you passed in your first semester? First, first year
फर्स्ट ईयर।
cleared? हाँ,
या मैम,
first year
फर्स्ट ईयर
is cleared?
क्लियर। यस
Okay,
मैम।
very good. Safa? What about Safa?
यस मैम।
You cleared your first year, right?
Yes, ma'am, I cleared, but I was unable to clear the second semester.
Second semester is your, what is the syllabus? Topic heading क्या है?
एक काम भैया।
So you have textbook, Poonam?
Yes, ma'am.
क्या मैम बताए, स्टिल आई एम सर्चिंग।
In second semester, we had waves and oscillations.
Waves and oscillations. Okay, okay. Don't worry, Safa, I'll share you the important questions. If you have any doubts, you can ask me, no problem.
Okay, ma'am, thank you.
Okay, but I have only this third semester I have to take the classes. Still, I'll help you out to get good marks and pass तो हो सकते हैं, मुश्किल नहीं है। कैसे पढ़ना कैसे लिखना वो इम्पोर्टेंट है।
Yes, ma'am.
Okay,
Hmm.
so I'll share the screen.
सिक्स।
So next time I'll show my face. Okay. Next time directly I want to see your faces as well as we will be like direct interaction. So this was my first class. So next class on next Sunday, I'll be more ready.
ओके।
I just want to share the screen of your syllabus. Give me a second. So let me 8 minute. Desktop is not so clear. Just sorting out. Hmm. Can you see the screen,
Yes, ma'am.
Poonam and Sapa? Yeah, right?
Yeah, ma'am.
So
Yeah.
I just got this material. So before going to these topics, see, uh, in this contains kinetic theory of gases, zeroth law and first law of thermodynamics, reversible and irreversible process, Carnot's engine. Okay. So these are the topics first we will see. Okay. So क्या बोल रहे हैं laws of thermodynamics. This is what you have. This is the syllabus. Go through the syllabus. मैं करेक्ट पढ़ा रही हूँ या नहीं हूँ आप लोग मेरे को बोलना है.
Hmm.
ओके. सो
Yes.
क्या है आपका लॉस ऑफ थर्मोडायनेमिक्स है.
Yes.
बिकॉज इन द सिलेबस वही है.
Yes, ma'am. It's this only. Yeah.
ओके. डन.
Hmm.
करेक्ट है ना.
Yes, ma'am.
सो kinetic theory of gases है. Actually, we in degree third semester. This is your third semester, right?
Yeah, ma'am.
So difference तो है. Kinetic theory of gases में objective introduction, assumptions of kinetic theory of gases, mean free path, graphical representation of velocity, distribution of gases, Maxwell's laws of distribution of molecular speed, transport phenomena, viscosity of gases, define of viscosity, equation for coefficient viscosity, thermal conductivity of gases, diffusion of gases. Okay, this is all we need to go with the kinetic theory of gases. Okay, so what I just want to know is what is thermodynamics? First, before going to the topic, we need to go with the basics. That is very, very mandatory. Okay, so what is thermodynamics? Anything you can answer if you know anything. What is thermo? What is dynamics? First, we need to know. Okay, so much of basics. See, अभी physics पढ़ना है तो क्या करना? Physics is the assumption. We need to assume. We need to imagine. That is what is physics. पहले वो imagination world में थोड़ा जाना ही पड़ेगा. Okay.
Okay.
Electronics बोले तो input output. You can see with your eyes. Which you can't see through the eyes is about your physics. You have to imagine. Okay. And we have so many solutions and problems and we can do it in practically also. Okay, मगर ज्यादा थोड़ा you have to imagine. You have to go to the imagination world. Okay. अरे कोई और join होए तो और अच्छा है ना. I'll be more happy.
अभी मैम
सफा भी चले गई.
नहीं है। एक
हाँ.
मिनट, वो मैडम बोले लिंक शेयर करने के लिए, एक दो लोग तो जूम मीटिंग का पासकोड पूछे लेकिन वो ज्वाइन ही नहीं हुए।
पासवर्ड है ना.
पासकोड है बट वो वेबसाइट से जाके करना है, मुझे शेयर करने नहीं आ रहा है। एक
हम्म.
मिनट, एक मिनट।
See, I can extend the class if you people are really interested. I don't have any objection. Hmm. Uh, Titli, you also left. So no problem, Poonam. I have
यस।
no issues. I can teach you. Even if one student is very interested in subject also, I don't mind. I'll teach you.
ओके।
मगर सब लोग एटलीस्ट एक क्लास में ज्वाइन हुआ है तो अच्छा
नहीं नहीं,
रहेगा।
हाँ अभी ज्वाइन कर रहे हैं मैम, बस जस्ट वो
हम्म।
लंच का टाइम है ना, खा के सो रहे हैं।
ओके ओके। फिर तो हर संडे तो 12 to 1 ही रहेगा ना?
हाँ एक्चुअली ये फर्स्ट क्लास है, और
नहीं,
जो
फर्स्ट
कुछ भी
क्लास ही इतना इम्पोर्टेंट है। जो भी अभी बेसिक्स में पढ़ाती हूँ ना,
हाँ
वो
हाँ।
पूरा सेमिस्टर को हेल्प होगा। मैं फर्स्ट क्लासेस मैंडेटरी बोलती हूँ मैं। फिर एक बार
वो तो है।
समझ में आ गया तो यू कैन बाय योर सेल्फ, इफ यू डोंट अटेंड ऑल्सो यू कैन स्टडी बाय योर सेल्फ। मेरा फर्स्ट क्लास इज वेरी 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 इंपॉर्टेंट। आई स्ट्रेस माई स्टूडेंट्स टू अटेंड स्टार्टिंग क्लासेस बिकॉज द बेसिक्स जो मैं पढ़ाती हूँ ना, वो बेसिक्स से आपको ऑटोमेटिकली इट विल गो इन टू योर ब्रेन्स।
यस।
हाँ। सो वन मोर स्टूडेंट joined Jay Prakash.
Yes, ma'am.
Yeah.
या।
Hello Jay Prakash.
हाँ
So I
जय।
want your friends also to join immediately. It's already 12:30. आधा घंटा तो हो गया है। Ask your friends to join, no?
जयप्रकाश जी अपने ग्रुप में बताइए ना सब लोगों को ज्वाइन करने के लिए।
हम्म। जल्दी, क्विक।
हम्म।
Okay. Okay, I'm teaching. Shall I?
ओके
Or
ओके।
shall I wait? Or still some people are joining? Because see, we have very less time. Only 1 hour we have. And
या
every day we can't, I can't take a class. Only on Sundays. So I want you people to be more active and enthusiastic to join the class. 10 मिनट पहले ही ज्वाइन होके रेडी होना।
या मुझे लगा नहीं था कि लोग ज्वाइन नहीं करेंगे, नहीं तो मैं थोड़ा इसके मतलब टाइम रहते ही मैं सबको इन्फॉर्म कर दी होती।
Poonam, please take the charge, no? I'll be in
यस।
touch with you. You can take my
ओके
number.
ओके
Okay, you create a separate group. So ask them to join for my class. It's a humble request.
ओके राइट।
Okay. Okay. So before going to the direct topics of what is laws of thermodynamics, okay. One Poonam, you can be you can respond. Others, please mute yourself, no? So there will be no disturbance while talking or while I'm teaching.
ओके
Okay.
राइट।
So what is thermo means what? What is thermo? Chal, you have
थर्मोडायनामिक्स।
no. I'm just asking. You need to know. See, thermodynamics के बारे में पहले जानना है तो what is thermo? What is dynamics? Thermo means what? It's a heat.
यस मैम।
Okay. Thermo means
हीट।
yes. So generally we always call thermometer, thermal, everything, right? Which produces heat. So एक क्या है which is related to heat. If it is very cold, you can pour thermals. तो क्या मेंटेन होगा? Temperature can be maintained with the thermals or thermo. See, bottles also nowadays, thermo bottles we are getting, no?
राइट।
If you are adding hot water in that, minimum 8 hours, 6 hours or 12 hours, वो गर्म पानी गर्म ही रहेगा. That is what is thermo. Okay. So what we can call it as is a determinant and a word of forming element that relates to heat, hot, temperature. That is what is about thermal energy. So which can produce some heat. Clear?
क्लियर मैम।
Yeah. So the topic itself is we are studying about the laws of thermodynamics. Okay. And what is dynamics? Now you know what is thermo. Now we need to know about the thermodynamics. Okay, उसकी लॉस क्या है हम बाद में देखेंगे. What is thermodynamics? So एक एक क्या है? It's nothing but it's a branch of physics which deals with the energy and work of a system. Okay, thermo means heat which we are helping to generate or energy or a work to continuously process some heat. Okay. So you have different laws of thermodynamics. That is zeroth law, first law, second law, and third law. This is the basics. See, that is has been given in this this block deals with the thermodynamics. In this block, learners are exposed to know the kinetic theory of gases. Also, they understand the zeroth law and first law of the thermodynamics. They also learned about reversible and irreversible process. So, reversible, irreversible process is very important. That I will discuss on that topic. Okay. So, Carnot cycle kya hai? Carnot's theorem kya hai? This all what we are going to do or study or learn is about nothing but a refrigerator. I'm telling you. Okay. In the first class itself, why we are studying about laws of thermodynamics, why we are studying, why we want to know is because refrigerator. The refrigerator, what it generates? Normally,
Cooling,
cooling
cool,
outside,
cooling.
but inside,
Yes,
through which it is making it cool? Through heat only, no?
electrification.
See,
Yeah,
you are getting external energy is being supplied, right?
right.
So what is that? It is nothing but a power, charge, current. Through that current, you are making that to generate some charge or thermal, and you are getting that as a cool. Cooling process is happening inside. So that process is nothing but reversible and irreversible process, and Carnot cycle and Carnot theorems are all this one by one. They have invented. Okay, they could find out. So then later on, we are able to use refrigerators. So whatever the physics which we are using right now, or whatever we are studying in your degree level, okay, that are the basics only. We are not inventing anything. We are not finding anything. Whatever the inventors have invented, the theorems, whatever, just we are studying. That you have to remember. आप बुक ओपन करके आप देखें तो बहुत मुश्किल लगेगा, मगर हम लोग क्या कर रहे हैं? सिर्फ वो लोग इन्वेंट करे, वो लोग जो फाइंड आउट करे, जो रिसर्च करे, एक्सपेरिमेंटल करे, वो सब हम लोग बेसिक्स पढ़ रहे. फर्स्ट ईयर, सेकंड ईयर, फाइनल ईयर is only about the basics. Okay, so there is nothing complicated by seeing the textbook or seeing the topics. You no need to worry. Only the thing is that you need to understand what is thermodynamics, what is kinetic theory, what is reversible process, what is irreversible process, what is Carnot is nothing but his name. Okay, what the cycle process he have made. That all we have to learn. We need to know. Clear? So first law, second law, zeroth law hai. Zeroth law is nothing about the temperature. What is temperature? So here in this block contains the following units. These are the units we need to study in this. So first zeroth law hai. So before going to kinetic theory of gases, I want to tell you about zeroth law and first law of thermodynamics. Kinetic theory of gases, I'll tell you. Okay. आप
Okay.
running notes लेना है. These are the basic important topics which I tell you every class. Okay, so what is zeroth law? It might be there in your syllabus. I have not seen, but I'm generally telling you. So note it down. So zeroth law is about temperature. First, what we need to find? We need to find about the temperature. So thermo means raising off or maintaining some heat. So first law is zeroth law that we are going to study about temperature. वो क्या है? Two systems in equilibrium with a third system. Okay. Though two systems equilibrium means I see whenever I'm going to tell you something, you please make it a note so it will be easy to you to remember. So equilibrium means the meaning of the equilibrium I'm telling you, which flows equally all the time. It does not flow one by one. Equally it will flow. Okay. Getting? So equilibrium means always it flows in one direction. Two systems in equilibrium with a third system or in thermal equilibrium with each other is nothing but zeroth law. So two systems, I am taking two systems. So one is one and two systems. Okay. And with the third system means what? Whatever the energy which is being transmitted from one energy to the another energy is equally transmitting the heat. Okay. So for example, in a room, temperature, what normally the heat which is being served for you will be the same heat will be served for another person also. It does not change. Okay, equally it is being distributed to one person to the another person or one object to the other object. So the two systems in equilibrium with a third system are in thermal equilibrium with each other. Thermal is nothing but which produces heat. Clear?
Clear.
Okay. Next is first law. So conservation of energy. So what is conservation of energy? What is the meaning of conservation of energy? Energy can change forms. See, but it is neither created nor destroyed. Okay, first law is conservation of energy. Energy can change different forms, but it is neither created nor destroyed. Total
Destroy.
energy equal. First law is
Conversion of energy.
total energy will be equal. For example, if I want to take an example of swing, Jula. Okay, the energy which I have forced to move from one place to another place, the energy whichever I have applied, that what happens? Ek bar I made the swing to move. Okay, so the energy which I have applied, it will be keep on moving from the same force. Force will be applied. So what it is that the energy, whatever it is being produced to that, in between I can't create or I can't destroy. समझ में आ रहा?
राइट, समझ में आ रहा
Okay, others are also hope. If you have any doubt, you can ask me. But once I am done with the topic, you please raise your hands or you can directly ask me. Okay. Second
है.
law.
Okay, ma'am.
Okay. First law is done. Zeroth law is done. Zeroth law is about temperature. First law is about the conservation of energy. Second law is nothing but entropy of an isolated system always increases. Means hot to cold. Heat to flow. Second law. Okay, I'll tell you what is entropy also. How this is can be isolated system. We will discuss more and more. Okay. So what is entropy? I'll tell you. That is about say second law and last one is third law. Entropy of a system approaches a constant as temperature, approaches absolute zero. That is what is about entropy. So we need to know what is entropy. I'm just going to teach you now what is entropy. Okay. So entropy is nothing but in physics we call it as it is in second law. Okay. So the matter and energy in the universe to an ultimate state of inert uniformity. Okay. Or we can call it a simple. We have enthalpy and entropy. Huh? So what is enthalpy? We need to know first before going to entropy, we need to know about enthalpy. So enthalpy is nothing but the measure of total heat. Okay, total heat present in the thermodynamic system where the pressure is constant. Okay, pressure is going to be constant in enthalpy. Okay, so we can call it as uh, internal energy also. Okay, P is nothing but pressure, E is nothing but energy. Then what, when we are able to find about enthalpy, so entropy is a measure of disorder in a thermodynamics. Entropy is nothing but a disorder. Enthalpy is to measure the total heat in the present thermodynamics system where the pressure will be the constant and entropy is a measure of disorder in a thermodynamics. So we are making the enthalpy and entropy. These are the two topics, enthalpy and entropy. Why I'm stressing about entropy and enthalpy? Before going to entropy, we need to know what is enthalpy. Enthalpy, what is doing? To measure the total heat present. Okay, so for one refrigerator, for example, I'm giving you, for one refrigerator, you need to know the watts, power, energy, consumption, everything will be there, no? Daily appliances, whatever we are using. Even if you take the iron box, okay, whatever the heat, whatever the electric supplies, whatever the heat which is going to generate, everything will be calculated. You can increase, you can decrease. Yes or no? Right? So to find out all that, we need to know what is enthalpy, how to measure the total heat present in that energy or thermodynamics, and pressure will be constant. And in entropy, coming to the next topic, that is entropy is a measure of disorder in a thermodynamics, which is not going to be in order. Clear? So where, however it want, it will be going. So that to find out, we are going to use the entropy. Okay. Why it is called as entropy? Why we are talking about entropy? Because we know enthalpy is a proper able to calculate, it is in order, and we are able to make a pressure as a constant, and we are able to find. But when coming to the entropy, because it is in a disorder, we are unable to make it an order in thermodynamics. To find out entropy only we are stressing. Enthalpy is proper. Okay. Why? Entropy is nothing but an irreversible process. A small amount of heat energy is incrementally dissipated or across a system. So you have a irreversible process in your entropy. Reversible and irreversible. Okay, so next third unit is your reversible and irreversible process. See, I'm just giving you the basic complete picture of your thermodynamics. So before going to that, I have discussed about zero laws of your thermodynamics, zero law, first law, second law, and third law also. But here you have only zeroth law and first law. And reversible and irreversible process. Reversible process क्या है? Irreversible process क्या है? Reversible is nothing but your enthalpy. Irreversible process comes under entropy. Clear?
क्लियर मैम.
Clear? Others, any doubt?
Yes, ma'am. It's clear.
Hmm? So, see, in your first unit or, sorry, first semester and second semester, you might be studied about your, what is vector, what is scalar, right? You all know what is vector and what is your scalar. Scalar, what is scalar, what is vector, do you know?
या मैम.
Completed? Yeah. What is,
Magnitude,
Represent
direction,
only the magnitude,
magnitude.
Perfect.
whereas the
So,
vector having
both.
direction
Both
represents
magnitude as well as direction.
direction.
Excellent. You people are excellent, really. So where you can find both in your vector means it is having a proper magnitude as well as direction. So in your unit one, in your semester one and semester two, you have studied about your how the energy is being transmitted in equilibrium. It will be flowing in one direction. Okay. So for example, if I'm taking the current, it will be in proper flow. So if I'm taking a current, example current ले लो. ठीक है? Current क्या होता है? It does not go in disorder. Electrons will be traveling from one place to another place equally. One by one, one by one. It is in order. वो रोबो मूवी में देखे ना? All robos will be in order. It will go one by one, one by one. Like in current also, all your electrons will be traveling one by one, one by one. Okay.
Okay.
ओके
Okay.
मैम.
So now अभी क्या पढ़ रहे हैं? We are studying about a thermodynamics where kinetic theory of gases. Your unit one is about kinetic theory of gases. So till now I've told you the basics of your thermodynamics, how the thermodynamics is going to be used and how, where, why we are studying about is about your complete irreversible and reversible and irreversible process. That is the main picture about your refrigerator. Okay. Current is going, but current is going means proper flow of current is going. So it is working. Electronic item is working because all electrons are going in proper. But here we are studying about kinetic theory of gases. Gases are involved, right? To find a refrigerator, gaseous states are being involved. So in gaseous state, what happens? All the gases, for example, if I'm taking a cylinder, okay, all gas is being filled in that. So you think that the gas which is being filled, it is having a proper order to come out as a what to say? The gas which is coming out is in proper order?
No.
Answer no, right? However, it wants the gases are releasing. So you are able to burn the gas and you are getting the fire, right? So in your semester 1 and 2, you have completely studied about a proper flow of charge. Proper flow of charge. Now we are studying in depth, little more, going little further. Okay. So in your semester 1, 2, always you studied about a scalar, vector. So all the time we are going to use a vector quantity. Why? Because you can find both magnitude as well as direction.
Direction.
But when coming to the scalar, what does it do? What it does do?
Magnitude.
Only magnitude.
There will be no direction. Because why? You can use that scalar as a temperature. It can increase or it can decrease. Right? In scalar products, scalar unit में क्या कर सकते हैं? You can increase the temperature. Temperature may raise, temperature may decrease. Okay. So that's why we always find out for vector analysis where you have both magnitude and direction, where it goes in one direction. If divergence, you have studied about the divergence, curl, vector, this all, what it does, the current whichever the flowing or the unit which is flowing, it will be in a proper direction. But when coming to the kinetic theory of gases, it does not happen like that. However it will occupy the space. So it will be connected, one molecule to another molecule, it will be connected in a zigzag model. However it will connect. But in your vector, it does not. It will be connect one by one only, in order only it will go. Example, you remember that robo movie. All small robots will be there, no? One by one, it will go. Okay. So in kinetic theory of gases, how it will connect? If one molecule is down, also it will connect. If one molecule is up, also it will connect. If it is in back, front, wherever it is there, it will be connecting in a zigzag model. You need to imagine. This is what is about the physics you need to imagine. So you have to imagine molecules are there. Molecules are connecting from one place to another place in a zigzag model. It can be connected in any way. Okay. So once your gas is being released, that's why you can light the what is? When you can light, automatically you're going to get the heat, fire. समझ में आ रहा?
Yes, ma'am.
That's why this gases does not have a proper shape. It does not flow, however, it flows like a vector. Okay. So, this is your third semester, which we are going further because you have understood about you semester 1 and semester 2. Little further adding with all that, we are going with the thermodynamics. How this heat can be used as a Heat can be used in many ways, right? Now we are using so many different appliances. That is what is about electronics. This physics is being completely whatever we have studied each and every step by step, that is being applied in electronics. Physics नहीं है तो electronics नहीं है. फिजिक्स के
Right,
बाद ही
ma'am.
इलेक्ट्रॉनिक्स है. तो पहले फिजिक्स समझ में बहुत इंपॉर्टेंट है. So then electronics will be very simple. On and off. Switch on करो, off करो. Output भी वैसा ही है. Okay, if you want to see how the charge flowing from resistor to resistor, पहले voltmeter ले लो, okay, resistors add करो, output, input voltage, output voltmeter. आ जाएगा. You can see how the current is flowing. If you are increasing the voltage, current automatically comes out. Input, output. You can check it out. But whatever we are studying in this physics, no, that is all been invented so particularly to find out all this electronics. All the appliances, whatever we are now using in your home, that is being invented by using all these techniques. The physics techniques, whatever this will never, another physics will not come. This is the basics and it will be lifelong. It will be ever. Other topics will be involved. ऐड हो सकता है टॉपिक्स और थोड़ा ऐड होता है, मगर ये जो टॉपिक्स हम पढ़ रहे हैं ना, दिस विल बी फॉर एवर. There will be no change in these topics. Some more you can add. Clear? So, kinetic theory of gases, the kinetic. So, kinetic means energy. Okay. What is kinetic? Means external energy is being applied. Kinetic theory of gases. Okay. So, before going to kinetic theory, we need to know what is kinetic energy. So, external force is being applied. Okay. पहले क्या करना, आपको इधर से उधर हिलना है. So, you need to apply some energy to move from one place to another place. Okay. The kinetic energy is the energy an object has because of its motion. If does not, see, for example, what I can give you example, you want to travel from one place to another place, right? पहले क्या करना, you need to apply some motion, you need to accelerate, or you want to drive a car, you need to travel from one place to another place. Kinetic energy is being applied. Okay, the force, you are giving some signal to your brain that हाँ चलो अभी इधर से उधर तो उधर तक तो चलो ये काम करो. All the time it gives you some message, then only you are applying the energy, external energy. Okay, applying a force requires us to do some work. So if you don't force yourself, you will sit stagnant. There will be no motion, there will be no acceleration, there will be no movement. That is what is your kinetic energy. So we know what is kinetic energy. So that is what we are applying in your kinetic theory of gases. Okay. So if you know what is kinetic energy, now we are going to study about the kinetic theory of gases. So इसमें क्या है? Kinetic theory of gases क्या है? So the gases which are being filled. Okay, if I'm taking some volume, okay, or container, clear? So उसमें क्या है? सब gases है. So kinetic theory of gases is a simple, historically significant classical model of the thermodynamics behavior of gases. How it behaves, I just want to see. So I've taken a container, I have filled some gases in that. That might be any gas. That might be carbon dioxide, oxygen, helium, lithium, niobate, whatever the gases if you take. The gases, whichever it is being taken and filled in a container, I want to see how these gas molecules are reacting to one to another. So what it happens, it connects to one molecule to another molecule, it will be ready. So when you open a gas, the fire, if you give a fire, it will definitely gives you a fire. Because why? All the molecules are connected, gaseous molecules are connected and it is ready. If you don't use your cylinder, there will be no wastage of the gas. It will be remaining constant. It will be ready by connecting. And if you start using some external energy, that is your kinetic energy, then the fire comes out. समझ में आ रहा है?
Yeah, ma'am.
Okay. Yeah. That is what is about the behavior of gases. Okay. So with the behavior of the gases, this thermodynamics are going to be used. What we are generating is nothing but a heat. With the help of the gases, okay, what we are doing, we are making the food quickly. It is easy now. It is simple now. There is no much efforts to be cook. There is nothing. Now everything is so simple because of all these appliances. And how we are using? Because of all these theories, all this invention, or all these experiments, trial and error method, they have done so much hard work. Now we are utilizing it so simply. If you go to BC or far more than that, okay, so it was not easy. In 70s, 60s, 50s, 40s, if you go back, it was not easy. It was very tough. Cooking process बहुत tough था. Okay, there is no light, there is no fan, there is no power, nothing. In 40s, 30s, 20s, if you go back, if you go to that days, it was very tough. Now we are using everything in so simple way because of this continuous process of research working. Okay. So now we are utilizing it so easily. Clear? How? So why we are studying much depth of the kinetic theory of gases is because of the gases which are being contained. For example, I have taken a gas cylinder, which is that a gas is being filled. Okay. So what gas is filled in the cylinders? Can you tell me?
Through pipe.
Huh?
Is it methane, ma'am?
LPG.
Methane gas.
I'm just waiting if others also. Hmm. Tell me.
Madam, kindly repeat once again.
LPG बोले तो
Ma'am,
बोलो.
Liquid
ma'am,
petroleum gas.
liquefied petroleum
Liquefied.
gas.
Exactly.
Yes.
Okay, liquefied petroleum gas is being used. That's why we are able to use that gas to make the fire easily. Okay, LPG is correct, but I just want to know the full form of that. What is LPG? Liquefied petroleum gas. Okay, which is helping to exist as a liquid. Okay, in the cylinder, and which is helping to convert as a gas. Okay, so like that, nitrogen gas is also there. How many different gases are there? So many gases are there. Okay, different gases will be used for to make it solidified, to make it vapor, to get the oils, or get so many different gases are used to use in different methods. Okay, can you just give me some different gases in atmosphere?
Nitrogen,
Hmm.
oxygen, carbon
Helium,
dioxide.
helium.
Uh-huh. Main is oxygen and carbon dioxide.
Carbon
Okay.
monoxide.
Yeah. Or see, normally what we can do in atmosphere means it comes under oxygen and carbon.
Nitrogen
Hmm.
and carbon dioxide.
Uh, See, the gases which has a greenhouses are carbon dioxide, methane, nitroxide, and ozone. That is fine. But normally in atmosphere, what we inhale and exhale is nothing but
Carbon dioxide and oxygen.
Okay. Mm, okay. So if we go much depth about the atmosphere gases, it is another topic. We can go, see, physics is the topic. If we start some topic, no, we can go to the depth of any topic. If I'm taking about the gases, we can go to the different gases in the atmosphere. Okay. Different gases which we are going to be used as an appliances. Hmm? Uh, as a what we can start some topic and we can go in much. Okay. That is about this. Okay. Next क्या है? Next is the topic about uh, introduction, assumptions of kinetic theory of gases, main three part, graphical representation of velocity distribution of gases, Maxwell's laws of distributions, molecular speed. Yeah. See, we need to find, see the gaseous state. Now we understood know how the gaseous states are going to be connected from one molecule to the other molecule. You have imagined, or you just go through in your YouTube, you can find many how these molecules are going to connect from one molecule to the another. It does not wait. See, one molecule is there ready, it will try to connect it to the another molecule in zigzag model or whatever the shape you take. It keeps on connecting and it will be ready. So the gas which is being released, then the fire, if you give the fire to that, it keeps on burning. The gases will be released and the energy of the kinetic energy is being keep on coming out, and the external energy, whatever you are making that vessel to be heated and the water will be boiled. If you pour in that vessel, first what happens? The vessel container will be heated up. Then inside, if you pour some material, that might be anything, water, the water starts getting boiled. Then it comes into vaporization. The process will be happening. It's a continuous process that we will see in a reversible and irreversible process. This is a step by step. First, we are studying about the gaseous state, how these gases are being connected from one molecule to the another molecule, how these gaseous states are going to be released, and how if you are giving some external energy is nothing but you are firing that gas, and the energy, the fire is coming out continuously, no? The gases have been connected in such a way that you are getting the fire continuously. If the molecules are not being connected continuously, what happens? It stops the fire. Yes or no? The beauty of this kinetic theory of gases is nothing but the gases which you are releasing continuously is making the fire to burn continuously. Hey, can
Yes.
you
Yes,
imagine?
ma'am.
Please imagine. I'm imagining. While teaching, I imagine. So I want you people also to imagine. So if there is no continuous process of the gaseous, if it is not releasing continuously, what happens? There will be no gases releasing and the fire will not, you can't cook, right? You can't keep on make the gas to burn. समझ में आ रहा है? I don't know I'm able to
Yes, ma'am.
connect
Yes,
you
ma'am.
people or not. So I'm
Yes,
just
Yes,
ma'am.
trying
ma'am.
to,
Yes.
yeah. So what happens? The flow of these molecules are continuously flow, making the gas to release. So the fire is burning and you are able to cook, or you are making the vessel to heat, water, cooking, rice, whatever the process is happening, it's a continuous process. Because of what? These molecules are connected one by one and it is keep on releasing the gas, and the fire which is releasing is the external energy or kinetic energy. That's why we are studying about the thermo. Thermo means the vessel. The vessel is getting heated up. See, gas hai, fire hai. If you are not cooking, it is waste. If what you are doing, you are making that vessel to be heated up. Thermo means heating up. So if you boil that water, at least that water which is being heated up, it will be stable for at least 20 minutes or 10 minutes according to the room temperature. Yes or no?
Yes, ma'am.
That is what is about the process of thermodynamics. So this is about your first, we have studied about the all this different kinetic theory of gases. Now what we have discussed, unit 2 is a law. So unit 1, unit 2, unit 3, unit 4. The 4 units output I have told you. Inside the topics we will definitely discuss. But output picture तो समझ में आ गए ना, what is thermodynamics, why we are studying, why it is being so useful with this theory of gases, how the gases are. See, if there is no gas, there is no fire, right?
Right, ma'am.
Gases have been connected so properly, you are able to burn your fire means the gases are releasing continuously, the continuous process is happening. So then gases are being released, the fire is coming out. So then what is happening? I can make that as heat or I can make it as a cool. That is your refrigerator. Okay, heating process can be happen. Heat is happening inside the refrigerator. The process that is very important topic. Later on I'll discuss. The process, what it is happening, it is generating the heat inside the machine, and the output is nothing but you are getting as a cooling effect. So there is no power means you will get any cooling effect or cooling will be happened. No. Because of all these gaseous states, which is able to make the process in such a way, it is processing the reversible and irreversible process to maintain sustainability of the refrigerator. Okay. The stabilizers used to be happen outside in the old models. Now the stabilizers are being inside in the refrigerators. Why? Because to maintain the power might be fluctuating. It might be more or it might be less. The refrigerator should not be affected or it should not be damaged. So we need always stabilizers. So now in the new models, the stabilizers are inside the refrigerators. In old refrigerators, the stabilizers used to have outside the refrigerator. Hey, can I? सबके पास advanced refrigerators होगा मगर you might be seen in your grandmother's or somebody's house where you might be seeing the refrigerators old refrigerators कैसा चलते थे हाँ okay in
No,
the
ma'am.
nobody have seen the old
No,
refrigerators
no, no.
all born
Old
in
one?
90s
No,
huh
ma'am.
all born in
No, ma'am.
90s and 20s only nobody
Yes.
have born in 80s and 70s hmm?
I'm 90, but not sane.
No problem. What you can do is you can ask your father, mother, or your grandfather, grandmother how the refrigerators used to work. And you can see in your YouTube also. You can refer the old refrigerators how it has been.
Okay.
Okay. Hmm.
Okay.
Yes.
Okay. So
Thank you.
what else? So for today, I want to wind up with this. Okay. So now what you need to do is your homework is, see, I'm not teaching each and every bit by bit. I'm going to give you the complete picture of the topics. Okay. So now you understood what is kinetic theory of gases, what is objective, introduction, assumptions of kinetic theory of gases, mean free path क्या है, graphical representation ये क्या है, ये आप सब लोग एक बार glance करना. This anyway I'm going to discuss you in the next class, but not so specifically. Okay. So now you got the complete picture how it is going to be used. So objective में क्या है? After going through this unit, you will be able to define mean free path, explain the distribution of molecular speed of gases. Introduction. So this is about your introduction. You just read it. Okay.
Okay.
I'm not going to read line by line and I'm not going to explain. I just forgot to tell you the meaning of collision. Okay. Collision is nothing but molecule to molecule connecting is nothing but collision are perfectly elastic. Okay. See, all molecules are connecting to one molecule to another molecule, another molecule. It is continuous connection is there, right? Right? So that is nothing but collision, colliding. So each molecule is being colliding. So this because of this collision, elastic process means it is having a elastic process. Okay, you just go through this. If not, we'll go if you want by reading each and every line. If you want me to explain, also I'll explain. But this is a complete picture of this kinetic theory of gases. Next is assumption of kinetic theory of gases. So what is this? If you want, also we will go through it. Mean free path. What is mean free? See, the mean free path is nothing but the molecules of gases move continuously. That's what we understood, right? So molecules have a mean free path means it is moving continuously. The flow of the gas is coming out from the gas and it is keep on burning the fire. Okay, molecules of gas move continuously with large velocities according to kinetic theory of gases. They collide with each other. At each collision, the speed and the direction of the molecules changes. The molecule moves in a straight line between two successive collisions. The distance is called free path. Let A, B, C, D be the free path. The average distance is lambda. Is nothing but travel between two collisions. So, continuous process is happening. Collision is happening, means connecting one molecule to another. So, how we can calculate, see if I'm taking a container, molecules are being connected, I just want to calculate. If I can calculate from one molecule to the another molecule or one collision to the another collision, I can calculate for n number of molecules. That is nothing but lambda is nothing but the distance which is being traveled from one molecule to the other. One molecule I'm taking as A, second is B, third is C, and D, so on.
N.
Okay. Where n is the number of collisions, yes, number of collisions are been happening, suffered by the molecule, and lambda is called as mean free path. Okay, we can define mean free path as the average distance traveled by a molecule between two successive collisions. So here you can have space is given below for writing your answers. Compare your answers with one given at the end of this unit. Define what is mean free path. So you can write it down in your own words. Okay. Clear?
Clear.
Okay. So we will go depth by depth, depth by depth. So this is my first class and you are also attending the first class. So the thing is that I can stretch the class more, but I don't want to stretch because I have given you the input so much. It is there now in your brains. What is thermodynamics? What is kinetic theory of gases? What is different laws of thermodynamics? And what is how this kinetic theory of gases are going to be colliding with each other and how the gaseous state is coming out. So much we have discussed, no? Within 30 minutes class, not more than that. Okay. See, till now, whatever I have given you the complete inside and outside picture of your thermodynamics. That is your main first topic is about the kinetic theory of gases. So I want you to go through it. This I'll share you. I think you have.
Yeah, ma'am.
This is
Yes, ma'am,
this
we
is
have.
with you, right? So no need
Yeah,
to be
ma'am.
shared. Okay. Anything else? Doubts? Any clarification? Anything to talk? Because I believe only the capacity of the brain while teaching, it will take more, not more than 30 to 35 minutes or 40 minutes. That's it. Even if we talk much more about the topic, it will be deviating. So whatever we are studying, first every class I'll be teaching about the minimum basics of that topic and I'll go to the topic. So in that also, we will go much deeper and deeper how it is going to be used in our daily life and appliances, whatever. So it is connected to, the physics is connected to our body.
Yeah.
Okay. Yeah.
Hmm.
Yeah,
Ma'am, can you
please.
share your number?
Poonam, you're
Yes, ma'am.
asking?
No, ma'am.
Okay.
I don't
Yeah,
know.
yeah. Yeah, take it, Poonam.
Okay.
You want me to give my WhatsApp number or normal regular number?
Give me, ma'am.
Huh?
Give me, ma'am, your
WhatsApp number is
WhatsApp number.
better.
Yeah, it's 99
99
89
89
333
333
457.
457.
Hmm.
9989333457.
It's right, Poonam.
Yes, Suhasini, ma'am. Na?
Yeah, yeah, exactly.
Okay, ma'am. Right.
Hmm. Anything
Poonam, I will
else?
create
So
the
next
group.
class, I want you people to connect before 10 minutes.
Right,
Okay.
ma'am.
Okay, exactly. See, we have only 1 hour. Every week, 1 hour only class should be done with us lots of topics to be discussed, right? So it is
Yeah.
connected. So it is connected with, see, first what we have done, we have studied about the complete picture of thermodynamics. Next, we went to kinetic theory of gases. Next is your loss. Next is your process of entropy. That is reversible and irreversible process. Carnot engine. So it is it's like a chain. If you don't understand one topic, you don't understand next. It is connected. So we don't have much time and very weekly once. Again, I have to recollect you all these things means it is not possible. So you need to go through it. You have to keep ready with your doubts or whatever. So next class, every class after, see, I'll start at sharp 12 and I'll be ending at 12:40. So another 20 minutes we will be discussing.
Right, ma'am.
Okay, that will be the process will be done from my end. So the topics will be covered, the basics will be covered, and it should go into your brains. Directly, it should go into your brains. The topic, whatever I teach, it should go. And you need to imagine. Clear?
Yeah, ma'am.
Okay. Okay, see you all. Nice meeting you. And I hope at least from next class, other peoples also join means because so many students are there and only today 7 participants. I can see only 7 students have joined. So ask your friends to join for next class also. Okay, ma?
Okay.
Okay, then see you all. Have a good day.
Okay. Thank you.
Yeah, welcome.
Okay, ma'am. Thank you.
Welcome.
Thank you, madam.
Welcome.